The next named reaction we are going to be learning about is Stephen reaction. So this reaction is actually used for the synthesis of aldehydes. So it's for the preparation of aldehydes. So what happens over here is we have nitriles. These undergo reduction in the presence of stannous chloride in the presence of stannous chloride and hydrochloric acid and form imines. So nitrile is undergoing reduction in the presence of stannous chloride and hydrochloric acid to give an imine. This imine undergoes hydrolysis to give an aldehyde. So ketones are not prepared by this method. It's only aldehydes that are prepared by this method. So nitriles undergo reduction. So it's a reduction reaction. So it undergoes reduction in the presence of stannous chloride and hydrochloric acid to give imine, which further undergoes hydrolysis to form an aldehyde. So let's write reaction, the general reaction that is. So RCN, that is a nitrile, is reacting with SnCl2, that is stannous chloride, HCl and dry ether. So dry ether is the solvent. This gives rise to an imine, RCH double bond NH. Okay, this is an imine. This undergoes hydrolysis, so H3O plus, for us to get an aldehyde. So remember, always for a reaction, it's better that you remember these two at least. And you basically have to replace the R with various alkyl groups to get the rest. So let's take an example. For example, CH3 C triple bond N. Okay, so this is reacting with SnCl2 and HCl dry ether to give us CH3 CH double bond NH. This undergoes hydrolysis to give us CH3CHO. So as I told you, ketones are not prepared by this method, and nitriles actually can be selectively reduced by using a substance called diisobutyl aluminium hydride. Okay, so that is dibal H. So nitriles can also be selectively reduced using a substance called as dibal H. So the general reaction for this particular while this particular reducing reagent is used is RCN is going to undergo reduction in the presence of dibal H and followed by H2O, and that's what basically you get the imine, and then that's going to undergo hydrolysis and we will get an aldehyde. So let me just write another example for the same, an example for this reaction. So CH3 CH CH CH2 CH3 CH double bond CH CH2 CH2 CN is going to undergo reduction in the presence of dibal H and hydrolysis. So it will selectively reduce only the CN group, the nitrile group, for us to get an aldehyde. So the double bond stays the same. So generally, if you use a very strong reducing agent, the double bond might also get affected. So we are using dibal, which will not affect this particular double bond. So you will get CH3, CH, double bond, CH, CH2, CH2, and in the end it will be a CHO. That's it. Okay, so that's why we're talking about dibal H, because it selectively reduces only the nitrile group for us to get an aldehyde. So that's basically, we'll get an imine, then we'll get an aldehyde after hydrolysis. It's the same step that is followed. Actually, esters also undergo hydrolysis. Esters also undergo reduction in the presence of dibalH to give us an aldehyde. So let's take an example of an ester. So CH3, CH2 taken 9 times, CO, O, C2H5. So this COO, C2H5 is our ester group. Now this is going to undergo reduction with dibalH followed by hydrolysis. No, actually, yeah, to give us an, so this C2H5 will get removed and we'll only have CO, and instead of O we'll be having a H. That's it. So CH3, CH2 taken 9 times, COH. So that is about Stephen reaction. Stephen reaction is specifically used for the synthesis of aldehydes. Ketones are not prepared using this reaction. So the general reaction is nitriles are getting reduced in the presence of stannous chloride and hydrochloric acid to give us an imine. This imine is going to undergo hydrolysis for us to get an aldehyde. So this one is the general reaction for the Stephen reaction. We use dibalH to selectively reduce the CN group, because if it is a very strong reducing agent, it might affect the other parts of the compound. So we are using dibalH. Also, esters can also be reduced to form aldehydes using a reducing agent, that's dibalH as well. So with that, we're done with Stephen reaction. In the next video, we'll be discussing about ETAD reaction. Do check it out.